Okay, so now we're ready to practice some working with these laws of exponents. So I have another copy so that I can show, we can refer back to this and I don't have to keep flipping my paper over. So the first example, y to the fifth times y to the seventh. If we wrote that out, we would have y times 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 y. We are not really going to want to do that every single time. But to start out, I'm going to be writing, this is going to be a situation where we would add the exponents together to total up the powers of y. So it's going to be y to the 12th. Next example, we have 3 powers of b, all with the same base, obviously. So we're going to add 4 plus 3 plus 2, adding our exponents. So b to the 9th, right? Add exponents. Right. Adding the exponents. This one has a negative exponent. And for the most part, we're just going to treat those like normal numbers. They still follow the same laws. So 8 to the 6th and 8 to the negative 2, we're going to add the exponents. Okay, but we're not going to do anything with the 8 other than keep it the same. Because 8 is just telling us what number that we're multiplying over and over again. So make sure you keep the 8. So 8 and then 6 plus negative 2 is 8 to the 4th. So with the first two, they were variables. So then we couldn't actually evaluate what they are. But 8 to the 4th, you can put that in your calculator and you're going to see it's a pretty big number, 4,096. So I would accept 8 to the 4th since it's technically all the way simplified down. As well as if you wanted to evaluate the actual number that it is. Either one is fine. Okay, so this one is y to the 5th raised to the 2nd. So this one uses the rule power to a power, which means we're going to multiply the exponents. So the answer to this, simplified, is y to the 10th, because 5 times the 2. Okay. Now we have seen for the first time a coefficient. Okay, so this 3 is not an exponent. So we now need to make sure that we're paying attention to which numbers are exponents and which numbers are coefficients. So if we wrote this out, if you're not sure what to do, always write it out. So 3a in parentheses to the 4th means we're multiplying 3a times 3a times 3a times 3a. And these 3's are just plain old numbers. They're not exponents. So it's 3 times 3, which is 9, times 3, which is 27, times 3, which is 81. So we have 81, and then we have a times a times a times a, which is a to the 4th. M to the 8th divided by m to the 3rd. I could write this out with 8 factors of m in the top and 3 in the bottom, but we just learned from our rules that we're going to subtract them, and we always subtract them from the top to the bottom. So this is going to be m to the 5th, because 8 minus 3. Another way to think about it is 3 in the bottom are going to cancel with 3 in the top, which is going to leave you with 5 in the top. Okay, again here, we really need to pay attention, because this 12 and this 6, they're not exponents. So don't subtract those. They are just normal numbers that are being divided. So you can think of it as division, or you can think of it as that they're going to reduce. Either way, it's the same result. The 6 is going to cancel out 6 up there, which is going to leave a factor of 2. So we have 2. And then we're still going to subtract. So these we're dividing. These exponents are going to be subtracted. So 8 minus negative 3, minus negative means you're going to add 8 plus 3. So it's actually m to the 11th. That was a tricky one. Okay. Now we have things inside the parentheses, again raised to the power of 3. So when you have things in parentheses that are raised to a power, the power gets applied to everything that's in the parentheses. So this is going to be, let's write it out. I'll show you. X cubed y squared times x cubed y squared times x cubed y squared. So I've written out what's in parentheses there 3 times. So you could just think about working with the x's and the y's separately because you can only combine powers that have the same base. So we have x to the third times x to the third times x to the third. And at this level, we're adding the exponents, which is going to be a total of 9 powers of x. And for our y's, we have a total of 6. Okay, or we could have employed the multiplication rule from the beginning, which is what we'll do from now on, now that we know how this works. So it was 3 multiplied by 3 and 2 multiplied by 3. All right. Coming down to here, we have powers raised to the powers, to other powers, twice. So the top sort of simplifies to y to the 8th. And the bottom simplifies to y to the 6th. So first we have to multiply the powers to raise a power to another power. And then we're dividing with the same base. So the final answer is going to be y squared, because we're going to subtract these as we cancel out 6 from the bottom with 6 from the top. Here again, watch out, the 15 and the 3 are normal numbers, they're coefficients, whereas these are exponents. So 15 divided by 3 is 5. Or 5 over 1, if you will. Here we have x squared over x to the 4th. So if we subtracted, we would get a negative exponent, which we haven't talked a lot about how to deal with when the answer has a negative exponent in it. But we can think this through a different way. If we have the 2x squareds canceling out top and bottom, we're going to have 2 left, but the 2 powers of x that are left are in the bottom. So I'm just going to put my x squared in the denominator of the fraction instead of in the top, since the higher power of x is in the bottom. And then y to the 5th and y to the 5th, those are going to cancel each other out completely and make a big 1, which just means my answer is 5 over x squared. Okay, the next one, we have a lot of parentheses. So check and make sure what these powers are applying to. So this power of 4 only applies to the c. This power of 3 only applies to the c. And this power of 5 only applies to the a. So we're actually not raising any powers to any other powers, even though we see a lot of parentheses here. And so really we're just multiplying all of these pieces together. So watch out for what's an exponent and what's not. So this 4 and this 3 are not exponents. So you're just going to treat them how you would treat numbers and multiply them. 4 times 3 is 12. Then we can combine our powers of c. So we have c to the 4th times c to the 3rd, which is a total of 7, and then times c to the 1st. So if there is no exponent, it's just c to the first. So we have 8 powers of c, c to the 8th. And for a, we have a to the first right here, and a to the 5th. So a to the 6th total. Okay. Let's do a few more here. So this is a very tricky one because we're squaring all of this. So if we wrote it out, it would be 7x cubed y to the 5th times 7x cubed y to the 5th. So if we do this without writing it out, we need to be very careful because we are going to have 7 squared, which is 49. Then we have x cubed squared, which is x to the 6th. And then y to the 5th squared is y to the 10th. So this is where you have to really switch gears when you're thinking about what it means to square something. Because squaring 7 means to multiply 7 times 7. Do not multiply 7 times 2. But yet for these exponents, you are going to multiply 3 times 2 and 5 times 2. So be very careful when thinking through an exponent being applied to a regular number and an exponent being applied to another exponent, because it works totally differently. All right, we're going to see that again right here. So when you cube or do any exponent on an entire fraction, it's just the fraction times the fraction again times the fraction again. So basically, you apply the exponent to the top and you apply the exponent to the bottom, because we have 4 times 4 times 4, which is 64. And we have x squared cubed, which is x to the 6th. So again, if we did this without writing it out, we would have to be real careful, because it's really tempting to do 4 times 3, which is 12. But that's not right, because it's 4 times 4 times 4. Okay. Let's do 2 more, and then these others, they're really crazy, but I think you can try them on your own. So 2a to the 7th. Nothing really happening there. Just 3a squared and 6a cubed. So let's simplify the top and then do the division, because we don't want to bite off too much. We might mess it up. So in the top, we just have a 2 times a 3, so that's a 6. And then a to the 7th times a squared is a to the 9th over 6 a cubed. Those cancel out completely and make 1 because you're dividing them. And then we have a to the 9th and a cubed. So 3 powers cancel, and that leaves 6 powers of a in the top. So a to the 6th over 1, or just a to the 6th. Okay. When you have a big fraction raised to a power, it's really helpful if you clean up and simplify on the inside before you do the cubing, because then you can have your numbers get smaller before you cube them. So I see I have a lot of powers of m's here, so I'm going to leave the cube for now and just clean up the inside of the parentheses a little bit. So m squared times m, that's m cubed. I have 2 and then 1 more. And then I have my 5 in the top. And then I have m cubed over m to the 5th, which means I have 2 powers of m left after they cancel, but they are left in the bottom, so I'm just going to put them in the bottom of the fraction. And now it's time to cube the top and cube the bottom. So 5 times 5 times 5 is 125 over m squared cubed m to the